All right, that was number 1. We can look at number 2 now. So it's stating, how can I draw the Lewis structure of H2O? So very, very easy question here, number 2. And maybe you can take a moment to think about this problem here. So how can I draw, what is the Lewis structure of H2O? So think about this problem, and then we will you can look at the solution here while we think about this solution here. So I'll give you a moment to think about this problem. Think about valence electrons in terms of oxygen. We have 6 valence electrons on oxygen. We can think of hydrogens having one electron on the outside, right? So think about those things, and how would bonding affect those things here? So let's draw this out first. So I have H2O, right? Which means I have basically 2 hydrogens. I'm going to say I have 2. Let's see, come on, pen. There we go. I have 2 hydrogens and I have 1 oxygen, right? So usually the atom or the element with the most valence electrons belongs in the middle. So I'm going to say O here, and I have 6 valence electrons. So I have 1, 2. So I have 1, 2, 3, 4, 5, and 6, right? So 6 valence electrons, which means the hydrogens have to be on the outside, right? So my hydrogens, I have 1 here, and I can say maybe hydrogens can be 1 here, right? So these are going to bond, right? Like, as you can see here, these 2 are going to bond. It's going to make one bond, and then these guys are going to make a bond. So you can say that I have, so this will become O here of 1, 2, 3, 4, 6, 7, 8. I have H here on this side here, and H side on this side. So therefore, you can say that my Lewis structure will look something like this. However, if you want to be technically correct here, again, we have 6 valence electrons on oxygen, 1 electron on hydrogen. These 2 are going to make a bond. These 2 are going to make a single bond as well. So therefore, this is our Lewis structure. If you want to be very, very technical in terms of saying what this is actually, it will actually create a bend structure. So like just because here I have lone pairs on oxygen, right? So here, these guys here, the pairs of electrons that are not participating in bonding are lone pairs. So this here is a lone pair in red, and this here is a lone pair, right? What the lone pair does on this oxygen is going to actually draw electron density, so it creates a dipole moment, right? So I have this oxygen here and oxygen here. These guys, these lone pairs don't like these bonds here, right? So they're going to kind of create a lone pair. So there's actually kind of a partial negative charge on these electrons here. They're pulling electron density away from hydrogen here. So the partial negative here, and this is partial positive here. So this here is actually a polar molecule because of the dipole moment that exists, and we know it's water, right? So because we have the intermolecular forces, we have hydrogen bonding here, and we also have a dipole moment here. We have dipole. So we have 2 kind of intermolecular forces here. I'm going obviously above and beyond this question here when I say that, but it's saying how can I draw the Lewis structure? This is how you draw the Lewis structure diagram here. So again, this here is our correct answer. And then if you want to form the bonds here, this one is even better here. Use drawing a bent structure here. So this one's technically correct, but geometrically, because of the lone pairs pulling electron density away, it actually looks something like this in terms of Vesper theory when we're talking about lone pairs and creating a bent structure. The solution is correct. Diagram is technically incorrect because of the bent structure, because of Vesper theory. Vesper theory that states that lone pairs draw electron density away from the molecule, therefore creating a bent structure. But solution here is correct nonetheless. I don't think you're expected to know Vesper theory anyways in grade 11, so it's totally fine.